Hello again. Kevin Cole, PM Head of Cloud Management Solutions here at Supermicro, continuing our podcast on building a supercluster AI. In the previous video, we focused on how we built the supercluster based on discovering that entire rack in the configuration, and exposing various telemetry, sensor data, and day zero through day two lifecycle management. We also indicated that how you essentially discover the rack is very much different than how PodView discovers individual appliances that are associated with a rack. So I'm slightly going to change the narrative here and really focus on a very interesting compute called the GB200-NVL4, which is something new that Supermicro is bringing to market. And it's really I think a very good and small investment for those neo cloud data center operators that are really starting to get skin on the game, really understand the purpose of AI Factory. And with a small investment of maybe starting with one or two of these devices and then building upon the momentum of neo cloud or high performance cluster compute. Relatively, the GB200s are somewhat expensive, and the lead time sometimes can be uh, uh, several months before you can actually deploy it and get your data center or modern AI data center up and operational out from the ground, right? So by starting out really small with this and building on that momentum and going through a super micro sized rack configuration and adding as you need as you have additional tenants or workloads that come on board. I'm going to log into our sandbox here where we have exposed this GB200 NVL4 compute host. And so let's log into our sandbox here and let's dig into it and see what we see in regards to server management of the GB200 NVL4 configuration. All right, we're going to log in as admin. And as I discussed before, we have the ability to do Active Directory or global admin coming in, or whatever user that you assign to your role-based access control. In our case, we're going to come in as super user here, and we're going to type in our password. And what we do here is we come directly to the dashboard, which is the read-only dashboard, which provides a high-level value or high-level observability into your data center. So this is nothing different. We've discussed this on previous examples here of coming in and navigating through the GUI. So in this case, I'm going to really go to the compute section here where we actually list all of our elements or compute servers that have been candidates to be monitored, managed, and alerted. And I'm going to drill down into this one here, which is the ARS 121GL MB2B-LLC and the NVO4 GB2. It is a liquid cooled server, 1U form factor, that really is a great entrance point to start building a neo cloud and high performance cluster. And the price tag is pretty reasonable comparative to any of the other large deployments of GB200 and GB300 rack configurations. So let's take a look at that server here. And we're going to click here. And what we do here is, as usual, we provide a front and rear view of the particular 1U compute host. And then over here under physical assets, we provide additional information here in regards to the product SKU here, the motherboard type that we utilize, the serial number, form factor, the manufacturer, of course, is Supermicro, the BIOS version, BMC version, and various different states that this particular server is in. So we have a system state of enabled, the power state is on, and health is in good standing. And as always, we provide all the various lifecycle management buttons that are required to be able to provide lifecycle management of this particular individual server. And the purpose of SCC is really at scale to provide an enterprise management solution for your AI infrastructure at scale so that you don't have to click on each BMC and be able to collect the data that you need, which obviously slows down your data-driven decisions. So we have the carousel view on the top here to provide you at a high level the various different components that are inside this particular GB200 and NVL4. It is a Grace type of server with an ARM processor in here, and we can look at the CPUs in a moment here. But let's dig deeper on the left-hand side quadrant here, and let's break out the various different features or attributes that you can pull from this particular server. So the processor here is a 72 core processor. It has essentially two NUMA regions associated with it, or two types of CPU cores. Both are 72 core, and also here provides the health rollup and state of each processor. And then from a memory perspective here, you can look at the various different NUMA regions that we expose here within the platform itself. We have a little bit of a bug here. We'll get that fixed here with memory um, associated with this server. So it looks like the redfish endpoints are not being pulled here. So we'll take a look at this in our lab here. We're still actually testing this to make sure that it's going to be validated with the next release that we push out the door, which will be in a couple of weeks. And then we provide local storage information here. As you can see here, we have quite a few NVMe drives here in this particular server. And I want to also mention here, which I never mentioned in previous videos, about this nifty little UID that we can basically blink here when the drive has failed within your data center. So easily we can click on that and be able to associate or basically turn on the UID there to indicate that that drive has failed, so that when you send an individual out to replace the drive, they know exactly which drive they need to replace. Instead of doing a faux pas here of replacing the wrong drive, which may be the operating system on, and then you have bad news bears there. So that's a little bit on the local storage perspective. And of course, if you had any type of storage servers in there to support the Marvell or the various LSI type controllers for RAID, we provide the full RAID capability of RAID 0 through RAID 60 in your configuration. As far as adapters are concerned, we provide NIC information here that we need to pull. We're still working, obviously, on the interfaces there that can be exposed here, still in validation for this particular server. And then also we have the GPU information here, which is the GB200 and then a 186 GB type of accelerator. So we have 4 GPU accelerators in this particular server. And what's unique also, which I didn't mention, is being able to dump all the components that are inside this server and making them available through a CSV file, JSON file, a YAML file. And you can use that for obviously data mining or forecast planning or various other types of use cases on regards to pulling that metadata and dumping it into a tarball file and maybe importing it into pivot tables or some other type of application that you want to be able to data mine the metadata that you're pulling from this particular server. And then, of course, we have the FRU here and also the DMI and then also analytics as well. So in the actual what we're referred to as the DMI or the FRU, we have this button here to be able to edit this information, right? And we talked about the importance of compliance and governance in previous videos, where if you deploy any operating system to this server, or perhaps some other issue is based on you need to reboot the server based on changing FRU or DMI, we have those checks and balances in place, right? So if you have an operating system deployed or any allocation of assets to this server, it will result in not being able to make the changes to the FRU or DMI because that would require you to reboot it. So, and then of course we have also any of these buttons could be grayed out dependent upon if we have a health rollup issue, right? Maybe perhaps we're a critical rollup and the server is basically compromised. We wouldn't allow you to make changes here until you really mitigated those issues or fixed the server. Maybe you've had some component failures inside the server, which resulted in a health rollup issue. On the left-hand side of this, you notice here we also have information here about a tree view architecture, right? So everything from what we call a single chassis, in this case, it's a single 1U, to multi-chassis configuration. So we've talked about this in previous videos of how the tree architecture bubbles up into what we refer to as at a drawer level when inside the rack, to a rack level, to basically a pod level where that's groups of racks based on common workloads, up to basically a data center layer. So that completes this particular discussion on the NVL4 platform that supports high performance cluster compute and also neo clouds, and being able to get started with a relatively small investment, maybe a small startup, and require not a lot of assets to start with. You're still continuing to go out and explore, discover different tenants for the various workloads that you need to be deployed within your modern AI data center or AI factory. So that completes this session today. Thanks for joining, and we'll see you next time.